development team, and today we're here to talk about av-evasion while utilizing the Veil framework.
And just in case whoever didn't quite figure out our logo in the top right corner, it's a wolf in sheep's clothing with some claw marks or something between it, and that's our favorite hashtag, AVLOL.
Something like that.
So my name is Will Schrader. My handle is Harmjoy. I am a former National Research Lab keyboard monkey. I'm kind of a pure CS guy. Been doing security for a while. I love to break stuff, like I'm sure 90% of the people here. About a year and a half ago, started getting pretty interested in doing av-evasion research. Teamed up with Chris and Mike Wright. We started brainstorming, started coming up with a solution to these common problems. Then a year and a half later, here we are presenting on the Veil framework, Veil-Evasion, Veil-Catapult, and we'll hope you enjoy the presentation.
My name is Chris Trunser. I'm also one of the developers on the project. I started off as a technical writer and realized that that was not the path that I really wanted to take. So I moved into a sysadmin role, was able to get a fairly good technical background there, and realized that what I love to do is try to break stuff, change technology, and try to make it do something that it's not supposed to do. Found out that pen testing really is like my niche. That's what I love, and was lucky enough to be able to find a job doing that. This is my first major development project. Never really developed in anything before, so it's been a pretty massive learning experience, but it's been a lot of fun. Mike Wright is also one of our developers. Unfortunately, he wasn't able to make it today. He just got pulled away on an assessment, but I know he hopes everything goes well today with us. And all of us are developers for Varus Group. We're really lucky to be able to be working with them, and we love trying to do some sort of research at night, trying to develop new techniques to bypass antivirus and any other interesting research for us. So our overview. We want to kind of talk about the problem that we encounter when we're on assessments. It seems to be, quite obviously, everyone has an issue trying to bypass antivirus. Typically, obviously, this is going to happen if you're in a pen testing role. When we encountered this issue, we wanted to come up with something that would help us get around this problem. So our solution, our implementation, was Veil-Evasion. We created the Veil framework, which Veil-Evasion largely is part of, and we're going to show a couple different demos on how to actually use evasion to bypass AV. The next thing that we want to do, though, is, okay, we have this framework in place. We want to figure out how can we extend the framework and add new capabilities to the tool. Well, we came up with Veil-Catapult. Catapult is our payload delivery tool. So it's going to let us actually transfer and move our payloads that Veil-Evasion creates onto our target victim machine. And then finally, we're going to kind of go over a couple different how you can actually try to stop us and the different techniques that Veil-Evasion uses. So our problem, VirusTotal encompasses a lot of what our problem is and the different solutions that it uses. As you can see right here, this is a stock Metasploit executable uploaded to VirusTotal. We're getting hit with roughly 35 out of 46, so a solid majority of the different AV solutions that are out there on the market. The problem is when you're on a pen test, that's an issue. We can't reliably try to generate Metasploit freely available backdoors without worrying that we're going to get caught by different AV solutions. So we wanted to try to figure out how can we not spend assessment time developing a custom backdoor on site and waste time actually developing that versus assessing either the web application or the network or whatever it is that the client wanted us to look into. So that was our main target. So our solution, we wanted to have a couple different attributes. Malware obviously gets around and bypasses tons of different AV vendors that are out there right now. Great example is look at Target and the malware that was implemented on their point of sale.
Like, it just came out that the specific POS malware used in Target wasn't detected by any of 40 plus major AV vendors. So it's a very real issue.
So we wanted to have the capability to bypass AV as easily as other malware authors are able to do so right now. The next thing is we wanted to make sure that we didn't have to roll our own backdoor for every single assessment, because obviously that's going to have assessment overhead that you're using developing your backdoor rather than assessing your customer system, network, et cetera. And finally, a common implementation, and probably the majority of ways that people try to bypass AV is through including shellcode within the executable. So we wanted to try to figure out a method of including shellcode and bypassing antivirus that doesn't get caught, obviously. So our solution was Veil-Evasion. As you can see, right here is our UI that we commonly that is loaded. We have currently 24 different payloads in the framework. These are a variety of different commands that are available for use. We'll go over some of them throughout this presentation. We also have multiple different command line switches that can be utilized so that you don't actually have to invoke the menu system if you don't want to. You can just as easily write a script and generate a massive amount of payloads, or as many or as few as you want the entire time. So our approach, we wanted to try to aggregate as many available public techniques that are available on the internet and potentially currently being utilized by other tools as possible. If techniques are already known, I mean, you would reasonably think that AV vendors should be able to protect against them. The number of tools do utilize existing techniques, like I said, such as Pi injector, syringe, shellcode exec, a variety of different tools for Python-specific based payloads that are used to bypass AV. The next thing is we wanted to try to automate the backdoor development process or creation process and make the tool as usable as possible. One of the biggest issues that we have when we're in assessments for us is I want to be able to know that when I'm creating something or having to use a tool, that it's as reliable and usable as possible. The death to me of preventing from using another tool is if it's unreliable, it's going to crash, it's going to error out. I can't use a tool in my assessments that I can't rely on. So we wanted to try to make sure that our tool accounts for as many different error states or potential invalid inputs as possible. And finally, we wanted to try to implement, if it is possible, a number of different shellcode-less interpreter injectors, if you will, that obviously would not rely on shellcode in order to create or get our backdoor or callback. So the ethical debate that we had our team spanned many days and many conversations. This was something we didn't take lightly. Essentially, you can state that we're releasing a tool that could be utilized by obviously the white hat community for legitimate purposes, but we also were potentially worried about its illegitimate uses or for its unintended side effects by other people. This is something we tried to debate and figure out what we wanted to do, and eventually we thought that the risk of others using it outweighed the benefits of it being, of the white hat community having the same capabilities. Also, we tend to think professional pen testers in the white hat community are probably a few years behind malware developers out there right now. There are different techniques that are utilized by them to bypass AV that we may not have known yet or are just slightly a few years behind. And if malware authors have the capability of bypassing AV extremely easily on demand with however they want to with their methodology, why shouldn't the white hat community? So our case, we feel like, aligns fairly closely with the exploit disclosure debate. It all depends on how people want to think about it. Obviously, you have your full disclosure versus legitimate protected disclosure. But we feel that we obviously think that releasing the tool or releasing that and will benefit or outweigh the benefit, outweigh the cost of actually not releasing it. So our take is obviously we chose the path of full disclosure. We wanted to help the security industry better emulate sophisticated threats if possible and be able to generate payloads as quickly as possible so they can spend their time on an assessment without having to actually create this overhead research per assessment. The other thing is AV vendors can currently see our code. Obviously, we're an open source toolkit. All of our payloads that are generated by Veil have the framework and the skeleton, if you will, already freely available. So if they wanted to, they could go see the code and perform a little bit of research and development and try to generate their own ways of bypassing or of detecting our tools.
And part of the motivation here is we're hoping that if they actually do that research, then that will spill over and they actually might be able to block more legitimate threats beyond just pen testing tools.
So I believe it's May 30th we initially released Veil, and it hit. These are actually comments directly from our Reddit thread, where we obviously had a lot of different people had different points of view whether it was a worthwhile endeavor to perform or not. Some people thought that so we initially released it with 21 different payloads, and it was thought that this is just going to get us right back to square one when 21 new signatures are written. Obviously, we haven't had that problem yet, but it met interesting public fanfare, if you will.
So the Veil framework. The initial tool, again, Veil-Evasion was kind of the initial offering. We've since expanded it to try to be a true framework and offer a secondary tool, which Veil Catapult, which we'll go over later in the presentation. So the features for Veil-Evasion. We can utilize all Metasploit-generated shellcode or custom shellcode. What we actually do is crawl your installed Metasploit installed tree, extract all the potential options for MSF Venom, all the specific payloads for MSF Venom and all the associated options. It's all loaded up dynamically into the framework. It's all tab completable, which we'll show. So we just wanted you to be able to use any single MSF Venom generated shellcode that you wanted, or custom specifiable stuff if you want to write your own thing. Third-party tools can also be integrated very easily. Hyperion was talked about a couple years ago by Dave Kinney at DEF CON. It's a self-brute forcing AES scripter that brute forces its own key in memory and extracts an existing PE. We can throw that in and very easily utilize it. PE Scrambler is another kind of custom scrambler and packer. And the Backdoor Factory is a pretty cool tool by Joshua Pitt. It actually identifies code Ks within an existing executable and takes this kind of custom tweak shellcode and can stuff it into those different code caves to backdoor an existing EXE. It's pretty cool. We could also throw that in pretty easily. And we have command line switches again for every single possible option. We try to cover all the bases. We'd love feedback if you think some of the switches don't make sense or something. But we wanted you to be able to integrate this into third-party tools as easily as possible without having to use an API or something. So an example on this is, if you're not aware what Armitage is very quickly, it's essentially kind of a GUI for Metasploit. It was built by Raphael Mudge. There's a paid version called Cobalt Strike, which we tend to use on assessments. But what's cool in both these tools, and the free version of Armitage as well, there's an attack scripting language called Cortana, which lets you extend the GUI and do event triggers and all this kind of really neat stuff. So we were actually able to build a script with custom menus and everything that very tightly and graphically integrates Veil-Evasion into Armitage or Cobalt Strike. So payloads can be generated, and you can also optionally hook all the PSExec calls for Metasploit's PSExec. So we wanted to make this as kind of transparent as possible to your workflow, to where you can generate this, it'll save it all off, and every time you PSExec, it'll substitute your custom av-evading payload right in, so you can get right by antivirus without having to worry about the stock MSF Venom stagers being caught. And this will be a bit of part of a demo later, but you can see here in the top left the Veil-Evasion menu part. If you click on payloads, it'll actually dynamically load up all the existing payloads available in the framework. You can choose that, specify a variety of MSF payloads and all this type of stuff for the shellcode injection, optionally hook the PSExec and all that fun stuff. So native compilation. This is, it's nothing revolutionary, but we felt like we packaged it in kind of a really easy to use way. A lot of the payloads we started with were Python. So the two ways that you can take a Python script and compile it to an executable is either with py.exe or PyInstaller. And they both essentially operate in the same way, and I know people have talked about this in some of the past cons, to where you can take the Python interpreter, all the associated libraries, and a specific Python script, and packages everything up into a self-extracting archive, or it has like a little loader on front and a zip archive on the back. When you run it, it'll extract it to disk, use the Python interpreter to invoke your whatever attack script, which could be shellcode injection or other malicious logic, and off you go. The thing with py.exe, you have to run it on Windows, and we didn't like having multiple attack platforms and all that stuff. So we're actually able to install PyInstaller under Wine and Python on Kali. Because we like keeping one single attack platform, and we felt like the de facto standard is Kali Linux. So we're able to do this, and it happens pretty transparently to the user. You don't have to configure any options or anything. You specify your Python stuff, and then it spits out a fully functioning Windows PyInstaller exe, and we'll go over that in the demo. And then for C#, which we started moving into this language for a few payloads, you can use the Mono framework, which can compile VB.NET and C#.NET to a Windows-compatible x86 and 64-bit .NET exe. So all those will run as long as the machine has .NET installed. And for C, we use MinGW32, pretty standard. And again, the whole theme here is we don't want to introduce anything into this framework that can't be compiled to a executable natively in Kali Linux, so we can keep a single monolithic attack platform for ease of use.
One thing to note, the reason that we chose PyInstaller and py.exe is because there are other existing or legitimate tools that use it, such as I believe Dropbox uses py.exe. We wanted to try to find something that can wrap up our Python scripts into a Windows valid executable that they can't just flag on PyInstaller or py.exe. So we want them to actually have to try to identify the underlying, or AV vendors have to identify the underlying source code, figure out if it's malicious or not, and then create a signature for it.
Or even better, if they can identify the behavioral patterns, which we'll talk about a little bit later. So module development. We wanted to give this to the community so you can implement your own obfuscation and av-evasion methods. So you can actually take any module, drop it into the tree, it'll be automatically loaded up as long as it's formatted correctly. The languages we currently support are PowerShell, C#, C, and Python. But yeah, you can just drop and go, so you don't have to actually publish these modules if you don't want to. We definitely would love if someone could, put a pull request into our tree, but we understand some people would rather, keep these things close to the chest. And there's lots of reusable functionality if you want to create your own specific methods. We have cryptors, randomizers, all that kind of stuff in a common library. And you're trying to emulate things like Metasploit as far as the standard types of obfuscation methods they have. And shellcode generation is actually abstracted out. So you have a little shellcode object. You can invoke it and not worry about having to think of where the shellcode's coming from, MSF Venom, and configuring all that stuff. The user will be prompted. That's all taken care of, and it'll just spit back, whatever specified shellcode string that the user wanted. And we have a more detailed, tutorial on our website, veilframework.com. And again, these slides will be posted either on our site or we'll tweet out about them later in case people want these references. And we also have a payload template in the tree that has a bunch of example stuff for the language names and how you structure it and all that kind of stuff. So am I getting caught? Chris mentioned VirusTotal, and I'm sure most pen testers know what VirusTotal is. So we really recommend you don't submit your payloads to VirusTotal, because if you're not sure of how it works, if there is a single positive detection rate by any of the engines, then VirusTotal, like in their terms of service, they tell you they do this, they take that sample and distribute it to every other vendor currently participating in the engine and say, hey, this is positively detected by these guys, maybe you should look at this closer. So a better way to handle this is you can actually query VirusTotal for the SHA-1 hash of any particular payload, and you can tell, has this been submitted to the engine or not? So we actually keep a running hash list of every payload generated in the Veil output directory, where we also keep the source and compiled results. And we modified Mubik's or Rob Fuller's VT notify script, which will alert us if a customer submits a payload to VirusTotal. It'll take up all the SHA-1 hashes, takes an API key, it queries the VirusTotal API, and then does a nice little alert and tells you, oh, something that you've generated in the past, say week engagement has been detected. And it's really cool for red team engagements that are spanning, more than just a few days. If you're going weeks to months, you can actually tell if the customer is onto you. And there's a link again for Mubik's original script. And here we wanted to show you just kind of how it looks, because we weren't able to demo this without internet. But you can just run check VT at any point from the main menu. It'll transparently behind the scenes take every single SHA-1, query it, and we showed an example hit saying, this particular payload with this hash has been detected. Okay, shellcode injection. This is kind of the meat of a lot of the methods that we utilize, at least initially. There's three main ways we'll dive into really quickly and how you can actually inject shellcode into memory. One of the original ones that are the easiest ones is void pointer casting, where you just take a unsigned character buffer, you stuff all the shellcode into it, you cast it as a void function pointer, and you pass execution to it. You just jump straight to it. And the caveat here is if that memory where the shellcode originally was is not specified as executable, depending on the depth protections of your system, this can fail with an access violation. So to get a more reliable method, and I believe this is what a lot of the Metasploit shellcode stagers use, is virtual alloc, where you'll just you take a virtual alloc call at the API level, the Windows API level, allocate a chunk of memory as read, write, execute. You use some other API calls to copy your shellcode in, you create it as a thread, and you wait for that thread to complete. A little lesser known injection method, but still pretty effective, is using heap alloc. So you can manually create a heap object, specify a part of the region as executable as well, read, write, execute as well, copy the shellcode in, do the same kind of thing. So dep and PyInstaller. This came about from a weird bug that we kind of came across with some of the Python payloads, to where the Python script, if you just ran it as a straight file on a Windows machine with Python installed, it would work. But the PyInstaller executable wouldn't. It would fail with an access violation on some of the shellcode injection methods, specifically the void pointer thing that I just mentioned. Luckily, PyInstaller is open source. We're able to search through and figure out that the little loader exe that they put on front of the self-extracting archive is actually opts into dep protection, data execution protection. So even though dep protection is normally, or it's been traditionally used as an exploit mitigation technique to keep pages of memory from being executed if they aren't specifically allowed to, this ruins some of the shellcode injection methods we have if the loader specifically opts in. But we can recompile it if we want to, so you can turn that dep off. We have a detailed blog post about how to use Visual Studio to recompile it and turn all that off if you want a more effective loader for some of these injection techniques. Okay.
So we do fully realize that memory injection techniques and recompiling PyInstaller is, or can be, a fairly complicated process, so we didn't want to really highlight everything within this talk. But if you have any questions, feel free to ask us after the talk, or just hit us up on email or anything like that. And it's a conversation we'd love to have. So our different payload releases. We created what we like to call V-Day, which is our victory over antivirus, we'd like to think. We tried to model this after Microsoft's Patch Tuesday, where we want to try to release at least one new AV bypassing technique each month. Currently, we have right about 24 different payloads that are available for anyone to use. And we have 20 or more additional payloads that we're keeping that we have for, that we're currently either QA testing or having to modify as we make changes to the framework. But we do plan on releasing them once we get everything set up and ready to go. And we're obviously going to be releasing for quite some time coming up.
And then even though there's only 24 of these existing payloads, some of them, like a lot of the Python methods, have a ton of options. Like you can use void pointer, virtual, heap outlook for all of them. We actually have expiration options, to where if you only want a payload to be, say, only active or only able to be triggered for the life of your assessment, say 1 to 2 weeks, you can set that to where if it's after that time, nothing will trigger. So even though there's only 24, there's a huge number of options for a lot of them already internally.
So shellcode list stagers. Raphael Mudge on his GitHub has an example of a post on how to actually implement your stage 1 within, without requiring shellcode. You can do it in a higher level language, such as C, C#, or Python. So we thought that that was really interesting, and we wanted to kind of take a look at that and figure out, okay, how can we actually implement these stagers without requiring any sort of shellcode within our payload? So we developed them, and we have 3 different languages right now that can be used. We have C, C#, and Python. And this is your stage 1, what you would normally think is your stage 1 executable that's dropped on a machine. The main difference for C, as you can see, is we have reverse TCP service. This is specifically used when you're invoking Metasploit's PSExec module because it wants to create a valid Windows service on the machine. But any other payload types, like the reverse TCP, HTTP, or HTTPS, you can just utilize as a normal executable generated by the framework and just drop on disk.
And the Python reverse HTTP and HTTPS we just released on Wednesday because it's the 15th and our January V-Day, I guess.
Yeah. So kind of how it's working, that was figured out that it was working, is initially when you have a stage 1 payload executed on your victim machine, a TCP socket is immediately set up and connects back to your Metasploit handler or your listener. Once that connection has been established, 4 bytes are immediately sent back to your victim machine, which detail the length of the DLL that's about to be sent, and then the interpreter DLL is actually sent to the victim machine. The raw socket number that the underlying OS, in our case, we only do Windows currently, that's used by Windows to maintain and recognize that section, or the socket, is pushed into the EDI register on the machine, and then the execution is passed directly into the DLL. So it's acting just like we actually are invoking shellcode, And this is the reason that we can do this is because the DLL has been made to be reflectively injected.
And if anyone's wondering, which there probably are 3 people are, on step 3, when you actually push that socket number into the EDI register, the reason this is needed is Metasploit does this nice, or Meterpreter does this nice trick. So instead of having to open up a secondary connection for command and control, it saves that socket number and then pops it off in the DLL, so then it can use that existing data transfer socket that it originally had to connect back as its CNC mechanism, so you don't have to do any additional overhead for command and control.
Okay, so we'll do our first demo just showing Veil-Evasion. So let's go to this. So the first thing that we wanted to show is that we do obviously have MSE installed and it's running on this machine, and we are up to date as of yesterday. Okay, so the first thing we'll do is we'll just go ahead and create a stock MSF Venom payload just to test it out.
Sure, probably most of you guys have done this, or some of you have done it.
There.
Can I go ahead and do it?
Shut.
Here, 1 second. Yeah.
There we go.
Okay.
Huh?
Wait a second.
I didn't hear. Go ahead. You talk.
So he's just doing, you know, most of you guys have probably done this a lot. He's just grabbing the IP and he's setting up, IP doesn't really matter. He's just setting up a stock MSF Venom EXE. Then we'll show just dropping onto the machine about how it's snarfed up.
Okay. So that should be created, and we're going to drag and drop that onto our Windows box. And right now, if we try to run this, MSE obviously caught it. So it's seeing that there's an issue, that it has a signature for it, so it's not going to work. So what we'll do is then invoke Veil-Evasion. So this is again what Veil-Evasion currently looks like. We right now have 24 different payloads loaded up, and these are the variety of different commands that can be utilized when using the tool. The first thing, in order to check all the different payloads that are available and loaded in the framework, is just listing them. So you can see we have C, C#, PowerShell, Python, and a couple native tools such as Hyperion, the Backdoor Factory, and PE Scrambler. So in this case, what we're going to use, probably one of the most common ones, is the AES encrypted payload. So to do that, you can start typing it and it'll tab complete everything. Or you can just give it the number of the payload. And so we have it loaded up right now. So right here are the different options that you can set for your payload. So like we said, we have 3 different techniques for memory injection. It's currently set at the default to virtual alloc. You can change it to virtual alloc, your void pointer, or heap alloc. We'll just go ahead and leave everything as it is, and we'll generate our payload. In this case, we don't want to supply any custom shellcode, so we'll just invoke MSF Venom. We can tab complete our IP and our port. And right now it's just invoking MSF Venom to generate the shellcode. And now I'll give it a name.
And here it's running the all the Pine Solar stuff through Wine right in the background. Just it shows a couple stats messages, but otherwise it's transparent.
Awesome. Yep. And so what this also does is this created a handler file, or basically it's a Metasploit resource script, where you can just quickly invoke Metasploit framework, pass it that resource file, and then it'll set up the handler for your Veil payload. So that's what we'll do now. And while that's getting set up, we'll copy our payload off. We'll make sure we're good. There we go. And I'll move this one over. So this is our Veil generated payload. The icon is PyInstaller, obviously. And we'll run it. And we can see we're getting our stage back.
And that's kind of funny you mentioned that, again, the packed Python PyInstaller stuff has been around for a while with Dave Kennedy's PyInjector and stuff like that. So this has been known for several years, and still, one of the largest AV vendors out there still just doesn't detect it at all whatsoever. So something kind of needs to be done. Is that all good?
Yeah, you're good.
All right.
Oh, this one.
Come on. Okay. So again, we mentioned how we want to have Veil be more of a general purpose framework beyond just Veil-Evasion. So the second tool, which we just released today at our website, veilframework.com, there's a big detailed post about it, is Veil Catapult. And this is our payload delivery system. What we mean by that is if we have a particular EXE, and say we have some valid credentials for a box on an internal pen test or external, if we dumped hashes or mimikatz or something like that, how do we get that particular EXE onto a box and triggered? So there's existing tools out here that have done this. The most classic one is Metasploit's internal PSExec. Again, the fact that their stock EXE templates are pretty easily caught is kind of what started us down this whole path. There's also a tool out there, SMBExec, which does something similar, where they use patched Samba binaries and WinExe to actually upload and trigger a executable. But we wanted something that had really tight integration with Veil-Evasion for on-the-fly payload delivery. And there's also a few gap areas that we felt like we wanted to build our own solution. We felt like we could cover a few of those things. We actually generate cleanup resource scripts for every single time a payload is uploaded or triggered. The big thing here is we want to leave a client box in a pristine state. We don't want it any different than when we left. We want everything cleaned off. We don't want to be leaving backdoors around and, the Windows System 32 directory from a failed PSExec thing, which has happened at various times. And we also, a big theme with the framework is we want to have very complete command line flags for every single option. So there's 20-something flags. Anything you would want to do with it, you can. Usually we want the full potential for third-party integration in case you wanted to use this capability.
So our cleanup scripts, like you had mentioned, will go in, and if you're actually dropping an artifact on disk on another machine, it'll kill the process and then actually delete that artifact off of disk. If you're running just something, maybe you're invoking it over a UNC path, it'll kill the process in memory so that it is no longer running also.
So here's just a quick UI. We'll go over some of this stuff in the demo. But it's the same kind of UI that we have for Veil-Evasion. We have standalone payloads, EXE delivery, cleanup, and we'll go over all these features. So EXE delivery, this is kind of the meat of Catapult, is users can invoke Veil-Evasion to generate a payload on the fly, or they can specify a pre-existing EXE. This will drop you straight into the menu for Veil-Evasion. So you have, as payloads and everything are released, as new techniques are released, you can utilize every single new thing that comes out just on the fly, transparently. And payloads are delivered in one of two ways. For uploading both of these, we actually use the in-packet Python SMB library, which you can utilize either plain text passwords or LM, NTLM hashes. We use that to upload or host. Then we use the patching the hash toolkit, which was released, I think, a year or so ago at DEF CON, which is a bunch of patched binaries that will run on Kali that will allow you to use either plain text passwords or hashes to run a variety of tools. The two main ones we use are WIMS and basically their version of PSExec, or the Linux version of PSExec, which is called WinExe. So yeah, again, the first method, we can upload a binary and then use an in-packet and then use one of those two specifiable methods to trigger it. And another method we use is we can actually, with an in-packet server, host the payload on our box and then trigger it with a UNC path straight to our box, and it will load straight into memory. And the funny thing about this is it gets some otherwise detectable EXEs, disk-detectable EXEs, right by some antiviruses, and we'll show that in the demo here. But interesting little thing that we came across was, while this will work for certain EXEs, which we'll show, if you try to use the UNC invocation on a stock MSF Venom stager, Microsoft Security Essentials will actually catch it at the process level. So there's kind of evidence that they're trying to block pen testing tools without actually doing proper detection, because they're just doing an in-memory signature for the MSF Venom loader. The standalone payloads, PowerShell, this is nothing too new. It's been around for several years. Everybody likes to do it. So we wanted to make sure we included the functionality. I think this is the first place that I read about it, at least. I'm sorry if someone else read about it before. But on Exploit Monday, they talk about exploiting various PowerShell features for shellcode injection, which is nice because no malicious binaries hit disk. The bare bones Python we'll talk about here in a second, but essentially it uploads a minimal Python installation onto a box, unzips it, and then uses that to invoke shellcode. And the setec backdoor, people have been using this for a few years, where you can issue a registry command that sets the debugger for setec.exe to be cmd.exe. And in plain English, this means once you run this one command and you RDP to a box, if you're on the login and you hit the shift key 5 times, a command prompt pops up that's running the system, and you can do whatever you want. We include cleanup scripts for this as well, for the setec stuff, because we want to be able to remove that. Cool. Okay, so the bare bones Python. This is our slightly novel solution to where we have a manually stripped Python zip file where this has the Python interpreter and all the libraries needed to bare minimally inject shellcode. So this is included in the tool, and we issue one command we use in Packet to upload that zip file with the environment. We also upload a minimal 7-zip binary. We issue one command either through WIMS or WinExe specifiable to unzip that whole binary, unzip the entire environment into a temp directory. And then we actually invoke a minimal Python program with -c, just kind of how you would PowerShell. So none of the actual logic touches disk. And this minimal Python program decodes a small little shellcode injection wrapper, injects whatever shellcode you want that's generated by Veil-Evasion, and the end effect is that the only files that touch disk are a trusted Python interpreter, known Python libraries, and everything else. It's kind of the Python version of trusted execution, and it gets right by a lot of reputation filters and antivirus. And the whole motivation behind this was, we like PowerShell, it's awesome, but still in some engagements, either it's disabled, or we have older machines, or something along those lines. And so internally, we wanted a way to have kind of this trusted execution concept without having to utilize PowerShell.
We'll be having a detailed blog post coming up pretty shortly, kind of documenting everything how this works and how it can be utilized by everyone.
Yep. Cool. So the second demo. Come on. There we go. So some of the systems were running a bit wonky, so we're going to cop out and have a video for this, but I'll talk everybody through it. Okay, and sorry if the font's too small, but I can't control this one because it's a video. So this is Armitage, the Metasploit kind of GUI. Sorry, I didn't start yet. We've already loaded up the Cortana script that exposes the graphical functionality on the show. So if we go out to attacks, Veil, and generate, you can actually see what the current PSExec custom payload is that we have set up for it. Sorry, this is bad. The main menu, you can choose whatever payload you want. These are all dynamically loaded up from the Veil-Evasion Framework itself. So we have all the Python stuff, we have all the C# stuff, we have all the C stuff, everything, like it's all loaded up. And if you update Veil-Evasion in the back end, this will be dynamically updated. An MSF payload, you can choose from a variety of ones, the standard reverse TCP, reverse HTTP, and some of the IPv6 and all that. We're going to change the base name for wherever the payload is. Once we generate it, this will actually run a Veil command in the back end on the system level. And here's what the output is. So you can just copy out whatever the output path. We wanted to make that kind of as easy to use as possible without having to go through the menu structure. So here we actually chose the C void shellcode injectable method. So this is pretty standard. It's detected by almost everything. We showing on a Windows 8 64-bit with Windows Defender. It says malware detected. It won't run. It ripped all the guts out of it. We'll quarantine. We also have a Windows XP SP3. We have a Windows 7 64-bit, so multiple platforms. This is Microsoft Security Essentials. You see it won't run. It's detected, whatever. Pretty standard. It's what you would expect. So it'd be really cool if you could take this exe that's otherwise detectable on disk and find a way to still trigger it on the system. So again, I'm sorry for the small font. We'll try to post these videos on the site after. What we're going to do is choose exe delivery, paste whatever the RD compile custom path is. We have an IP list that has all those machines already specified. We can do domains or just straight like local username. So we have a simple domain set up here with company.com, jsmith, and the super secure password to password, because no one ever puts that. And you can also use NTLM, LM. You can use WIMS or WinExe to trigger. We're going to do default with WIMS. You can either upload it, which is the default, or doing the host and UNC invocation, which I had mentioned. So we're going to actually host this on our machine. Sorry?
This is a video. This is a video.
Sorry. Yep.
No, we'll post it up.
Yep. Once you launch it, we just want to show an Armitage. There's no sessions right now. We launch this guy. It sets up the SMB server, hosts the payload, triggers all the commands, and we start getting sessions in, despite this being a completely detectable, super simple standard stager. Windows 7, just so you know we're not making anything up, is the Windows 8.1. And the stupid XP takes a little bit. Come on. I don't know why. There we go. Fast forward. Cool. So again, just kind of a neat little way that if you have normally detectable things, you can get them right by at least Microsoft Security Essentials. Cool. Again, stupid Mac. Okay, so how to stop us. And again, we promise we're not trying to hand out fully functioning cyber weapons for the hot word to whoever.
Drink.
But the thing is here, a lot of these stagers and a lot of malware has a pretty predictable set of behavioral patterns. So you'll have an immediate reverse connection back, TCP, reverse HTTP. You have rewrite, execute, memory page allocation, binary code copying, blah, 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 blah. It's a pretty standard set of patterns that you see over and over and over again. Most malware reversers, you see a pretty you don't see that many new tricks. Sometimes some pretty advanced stuff, maybe you'll see a little bit of interesting things, but for the most part, a small set of APIs are used in a very specific and kind of non-standard way to where Internet Explorer or something isn't allocating our RWX and then copying stuff in and all that type of stuff. And this is a great behavioral detection opportunity. So apparently, a lot of the AV vendors aren't quite doing this. So one thing that does do this, or you have the opportunity to write these types of rules, is Ambush IPS, which is a intrusion prevention system released a couple of years ago that allows for very flexible rules to be written at the Windows API call level. And you can actually do things like if a particular argument is passed that is a particular type of argument in a particular way is passed to a particular API call, and then a different call comes after that, you can chain these rules and actually have very powerful and flexible ways to detect a lot of these standard patterns. So you can actually write rules that will stop every single interpreter stager on every machine always, but not actually interfere with the normal execution for, say, Internet Explorer or whatever the programs you have. The website's ambuships.com. And again, Emmett, Rob Fuller-Mubix talked about this yesterday a little bit. It's Microsoft's Enhanced Mitigation Experience Toolkit. If you aren't running this, you should be. Just everyone go install it. It has a lot of mechanisms that stop the ability for an executable to inject shellcode. So even though this is kind of meant as a exploit prevention or exploit mitigation tool, these techniques still ruin a lot of the virtual outlet calls and things like that, because a lot of ROP chains and things like that are trying to achieve the same type of stuff that we do. It's just that we already control the EXE, so we don't have to go through all those steps. So the thing is, though, for Emmet, you can't enroll arbitrary executables like Robin mentioned yesterday. So people normally put them on the Adobes, the Internet Explorers, the Firefoxes, that type of stuff. But no one's talked about yet, at least I saw, so I apologize if someone has. If you enable Emmet for PowerShell, it'll ruin shellcode injection for PowerShell, period. So all of our techniques, a lot of the other techniques and different tools, anything that does lower level manipulation through PowerShell, you throw Emmet into it, or you throw PowerShell in Emmet, and that's all gone. So we're happy, I guess, in a way that we haven't seen this on assessment yet, but this is definitely would be a very effective mitigation technique against the new hotness of PowerShell. And there's a link down there that, again, we'll have the slides up for Microsoft TechNet article about Emmet, where to get it, and all those types of things.
So to find out more information about Veil, the framework, and anything you need, we have a website, which, like we said, hosts all of our changes. So anything we update stuff, we try to keep documentation as up to date and as well documented as we can. We have a bunch of different tutorials and just guides on how to utilize existing functionality within the framework to try to help teach anyone use the tool. It's also in Veil-Evasion is currently in Kali, but in order to get the most up-to-date version, we always recommend everyone go to our GitHub page because that'll contain all the most up-to-date code that you can get.
And, sorry.
Go ahead.
And we actually have Veil-Evasion is now split into a separate repo. Veil Catapult is in a separate repo. And that Veil Framework Veil is a super project which will pull down the current states of both those tools. So we really recommend that people use that super project. It'll set everything up correctly, set up scripts, it'll install all the dependencies, it'll install PyCrypto, it'll install PyInstaller, it'll do all that stuff transparently for you. So you just have to do this, run the setup script, and then you should have a fully functioning environment.
And that's about it. If anyone has any questions, you can hit us up on email or immediately after the talk or on Twitter, and we're happy to answer any questions that you guys would have.
We also have a RC channel on
Freenode.
On Freenode, it's just Veil.
Yep. Yeah, you want questions?
So with the Catapult, you talk about using PSExec. So with the Catapult tool, you talk about using PSExec and a couple of other methods of getting your malicious binary up on the system. PSExec has gotten me caught more times than I care to admit.
We will. We'll repeat the question.
Okay.
So is there a reason why you're not using WMIC to get it on?
Sorry, not using what?
WMIC, WMIC.
Again, the question is, why are we not using WMIC when PSExec is caught for a lot of stuff? I guess this tool just came out today, so that's something we can look into. We haven't gotten caught with PSExec, at least on the assessments that we do, when we use the PTH WinExe at least. So I don't know about if maybe the stock PSExec from Windows might get caught with the service binary, but at least through the in-packet library or the...
Creating a new service.
Yep.
So a new service pops up on machine X.
Yep.
Hits goes off the wall.
Yeah.
And then somebody comes knocking on, hey, you're the new guy in here, why is this
Yeah.
popping up?
That's why we included WMIS. So it doesn't create the service, but we'll look into WMIC as well.
So you mentioned that you're on Kali now. I've noticed that, for instance, with Metasploit, their turnaround time to getting in the Kali updates is ridiculously quick. Have you talked about coordinating with the Kali folks so that Kali always has your most current updates?
Sorry, it's about, but no, go ahead.
You go ahead.
Coordinating with Kelly.
Oh, so
Make sure Kelly has all the updates.
yeah, we do work with them. Basically, in order to update within Kali, it's a manual process. We have to submit to them, hey, we have a new version out there. Please go check it out and go add it into the repository. So we typically try to do it every month, but the OffSec guys are quite busy because they have a lot of different tools to handle. So the most like you said, the most up to date is on GitHub, but probably later this evening we'll submit them an update for our release from today or 2 days ago, and to get the most up to date version within the repo.
Cool.
Awesome.
And that's it.
Thanks for coming, everyone.